All right, the actual, these are what we call proof statements. All right, these are formal proofs. That's what I was trying to do. These are formal proofs. So what I want you to do is I want you to take one piece of information and make a mark. And if it's not already listed over here, list it. So, for example, they tell you AB equals CB. So AB equals CB. But they've already marked it underneath the statement side. So we don't have to mark that one. Okay? They tell us BD bisects ABC. BD bisects ABC. Oh, okay, so that tells me that this angle is congruent to that angle. Now, there's nowhere over here that says this angle is congruent to that angle, so I'm straight up going to write that in. Angle 1 is congruent to angle 2. And then I need to say why. Well, that is the definition of an angle bisector. All right? If it says, if this is the rule that allows me to make those marks. Okay, that's how it works. I know this is true because of what it said, so I wrote that down. And this is the rule that allowed me to make those marks. Okay, that's the rule to, or you can say that's the rule that supports it. Okay. The other thing I can mark, oh look, well these are on top of each other. So I need to say BD and BD on there. And that goes with my reflexive property. Since they already give me my reflexive property, that is, and I gotta zoom in again, BD is congruent to BD. All right, and again, the reflexive property, you're gonna have to know that for the test. Reflexive property, essentially, something equals itself is what it means. Now that sounds silly, but that's what it is. All right, because of all of that, I can confidently say that this is two sets of congruent sides with an angle in between. So the side, angle, side postulate or theorem, I forget which one it is, tells me that these are two congruent triangles. Okay? Number 2, same idea. Start off by marking what we know. Okay, well, they already told us AB and CD are congruent. All right, well, that's already there. CB is congruent to CB. Well, that's this guy in the middle. CB is congruent to CB. What property is that, you say? Oh, yeah, it's Mr. Hunter. That's the reflexive property. Reflexive property. Is it property or rule? Yeah, property. It's reflexive property. Let me get that down. All right, the last piece of information. They tell us these lines are parallel, these pieces right here. AB is parallel to CD. So because of that, remember, here's your Z. All right, and with your Z, you know that this angle, those two little nooks, are congruent. So let's mark those. Angle A, B, C. Remember, put the middle of it first. Middle of it in the inside. I mean, not first. Is congruent to angle. And we're going to put the C in the middle on this one, so B, C, D. And the reason for that, remember, parallel lines with transversal, they have alternate interior angles. Now, if you just put, honestly, for my students, I don't know about Hegman's and rest, but if you put alt int angles like that, I know exactly what you mean. That is alternate. Wow, I cannot write when it's this spaced out. I gotta blow it up. Alternate interior angles. All right, now that all that's marked, I have two sides with an angle between. So again, it's the side angle side. My postulate or theorem, one of those two. Cool. All right. Like I said, I guarantee you'll have at least one or two of these on your test. You will have to fill it out. But if you mark something, say what you marked. and then say why you marked it, or find the place where it's marked, fill in whichever one of those is blank, you'll be just fine, okay?